Yo, get the speaker box loud, hitting that stuff till you hearing that sound.
Every visit to the Koenigsegg factory is a special occasion, but this time felt like an incredible look at the future. The new factory showcases the past, the present, and the future of Koenigsegg, and what you're about to see is an incredible leap of progress for one of the world's most pioneering hypercar brands.
We've moved in here,
Yes.
Our transmission and engine shop. So here we have 12 stations.
Okay.
Did we lose your calling? Oh, there.
Yeah.
Yeah, 12 stations. So these three are transmission builds for Jesko. One person per station, per gearbox per week.
Wow.
So this room has 12 stations. So we will also do the Gemera transmissions and the Gemera engines in here. So when it's fully staffed and fully equipped, it's a potential of 6 engines and 6 transmissions per week being Jesko or Gemera. So that definitely covers our needs.
It's a big step on then, isn't it?
It definitely covers our needs, yeah, exactly.
Yes.
But it's also if we're doing transmission or engines for others as well,
right?
As it is more than our own needs. So it's set up for the future. We're already, I mean, the Jesko engine and the Jesko transmission, we're already doing that one person a week per unit.
Really?
So
wow.
That's already happening.
So
and then we have 2
these
dynos down here.
Bay built then? You
It's
bay build
built,
each
yes.
one?
Yes.
Correct.
Correct.
It's fascinating seeing, I mean, the amount of times that I've probably asked you to explain it to me, how the clutching works, but it's fascinating seeing these gear sets.
There are some beautiful components here, that's for sure.
They are.
And some interesting pieces. Let's see what we can find. Yeah, I mean, this is a pretty cool piece. This is the
what is that?
Crown wheel. So this is our active diff here, actually, in the middle. So you put pressure here with hydraulics to get more or less lockup, and the gears are, well, the metal is like unobtainium, and with DLC coating, diamond-like coating for anti-friction and wear. It's really like jewelry, everything.
It looks like a prop that you'd find on a Star Wars set, but that's actually real, you know?
The shafts are pretty wild.
Crikey, look at that.
Like hollow.
And these are all stress tested to deal with crazy amounts of torque. Of course.
Yes, I mean, yeah, you found the funny part.
What is that?
It's a flux capacitor, of course.
Of course it is.
it's
the intricacy of it.
Yeah, it's like a Swiss watch, right?
Yeah.
And the surface finish and the details, and this is like years of figuring out stuff, ending up like this.
So there's years of R&D in that single part there.
We have high-speed rotating shafts transferring 130 bar, or maybe more, 140, 150 bar of hydraulic pressure for the clutches, with rotation up to 9,000 RPM. So there was a bit of innovation when it comes to sealing materials and things like that to make that happen, and also design and I mean, a gearbox, when you put 1500 Newton meters through a gearbox like this, on a microscopic level, it's like a jelly bean.
It's got some flex.
Yeah, I mean, everything flexes. Of course, it's designed to flex as little bit as possible.
Yes.
But when you put that kind of power through something,
something's going to move.
There is a little bit of jelly beaning effect. So you have to kind of make sure all the tolerances allow for that, and that the material can take it, and that you don't touch anything, and that it can take that flex under that load, and that it seals under that load. So it's just an interesting challenge.
Variables to end up here are vast.
I mean, to develop something like this from scratch hardly happens.
Sure.
It's usually like an iteration of something. This was not an iterative process. This was like, how do we rethink a transmission?
Yes.
And how do we make it work within a reasonable short period of time within a small team in a small company? And when you're done, it's kind of obvious what you needed to do, but in the middle of the process, it's you have to have faith.
Right. Just send it and hope for the best. So
like,
I suppose
I described it as jumping off a cliff with you have a sewing machine and some fabric and some thread, and you kind of stitch your parachute on the way down, and you need to make it work before you land.
Brilliant. It's a shame you don't see these things, really. You know, one of the things that I find fascinating about, you know, Koenigsegg and the engineering that you're doing here is the irony of it is half of it, or more than half of it, you don't ever see.
Right.
You know?
It's hidden inside,
Yeah.
of course. Yes.
I mean, look at it. What is that? It's just wild.
So here we have one of our 7 clutches. So we have 3x3 for forward propulsion, giving 9 gears. Every time 2 in compound. 1 gear plus another creates 1 gear set. 3x3 becomes 9. So, and then we have one for reverse with fewer clutches because you don't have the same torque need in reverse.
Right.
What's interesting is we're taking off on these clutches.
Right. Yes. This is straight from clutch.
This is like this was sitting on the crankshaft. This is our takeoff clutch.
That's so crazy. It's tiny.
How can that work?
I don't know. You tell me.
And it works brilliantly, and we never overheat them for like traffic jams or anything. So, well, it's hydraulically cooled, of course.
Yes.
It's inside the gearbox. It's not outside the gearbox. So it's all wet and cooled like that. And it's also wet between the discs. But we have a crazy short first gear ratio.
Sure.
So the takeoff torque is very, very low. If you have like a long first gear, like you can go to 100 kilometers per hour in first gear, you have a big differential speed between the input and the outputs. You have a lot of friction going on.
Right.
But when you have a super short gear ratio, there is very little delta speed. So you get very little torque and high RPM immediately going into it. So you can have a tiny clutch that doesn't overheat, especially when it's cooled. This is the biggest diameter flywheel kind of we have.
That's your largest.
Yeah, absolutely. I mean, some gears are a little bit bigger, like this one.
Yeah.
So that's a little bit bigger than that clutch, actually. But that's about the biggest diameter of spinning anything. So,
what were the sort of, I guess, what were the biggest unknowns when you were finally ended up with no flywheel?
Well, no one has ever done that.
Right.
So. It's like an engine needs a flywheel, is the theory. And we do have indoor, I mean, this is, all these gears that sits on the primary shaft, they are somewhat of a flywheel, of course, they rotate, but they're tiny. So to have that small amount of diameter on the mass has never been tried before. But the bigger engine you have, the less of a flywheel you need.
Right.
So that's helpful.
Yes.
And it's a lot of tradition going into flywheels as well.
Sure.
And it also makes the software tuning easier because everything becomes more sluggish.
Right.
So you don't need to react fast to catch the engine or not make it over rev or whatever it does. So you need fast control when you have fast reaction.
Right.
And as we make our own controllers, we can make
You can adapt to it.
Exactly. And then you get this motorcycle feel, which I've never experienced in any car ever. It's just different natured. The transmission makes the engine behave completely different because we remove the flywheel mass from the engine.
The way it revs is, it feels like a motorbike in neutral almost. It's just so light. It's wild experience. We knew it would have an impact on the engine, the transmission. But that it has such a fundamental change of character is just fascinating. Fabulous.
So
very cool.
Yeah. So here we're building Jesko transmissions. Here we're building test engines, and I think you had a little bit look of our MES system, which is something we're implementing throughout the company.
So these are like cloud-connected screwdrivers, effectively.
Yeah.
Yeah. Say I just joined. I'm here to build my first Koenigsegg engine.
Yep. This is our new production system to ensure we have quality and traceability in production. And to this system, we also have connected nut runners. So the nut runner and the MES system, as we call it, are communicating together. So in this example here, we are tightening the cam caps to the cylinder head. and they should be tightened to a specific torque, which is executed by electric nut runner here.
Okay, so you've got predefined torque settings, which are now set in this.
We see here we have this bolt that should be tightened.
Did that then automatically start off slowly and then start?
Yeah.
And that's something that you guys map in?
Exactly. There is different parameters where we can set speed, first torque, second torque, different tolerances of what we say is approved.
And you've had to map these across everything that gets fixed.
Yep.
They all have their own profile and their own torque setting.
All bolts should be torqued. So, for example, if we fail this one, we say, so we red marked.
So that flashes up that
Yeah.
component, or stage 6 in this case, hasn't been quite completed to spec.
Yep.
So from a quality assurance point of view, that's effectively
Yeah, it's
helping hugely.
like hard to do wrong, basically.
Right,
Yeah.
okay, yeah. Maybe you'll identify over the period of production at a certain stage, you might get a red stage.
Yeah.
And then you can go, okay, let's inspect that, right?
Right.
Yeah.
And the amount of info that you get both from the tools that you're using, but also from the operators that are interacting with it.
Yeah.
You can also get a little more information as to sort of why are we lagging over here, or why are we always ahead of time over here. And it might be that you have new operators that are still learning,
Yeah.
Which means that you will be losing a little bit of time here.
Sure.
Or it might be that we've when we've set up the whole balance for the entire car,
Yeah.
it might be that some things take a little bit longer than we expected. Might need to add a little bit of leeway for adjustments.
Koenigsegg, we have no other example of things and subjects that we filmed over the years where the comment section is, "Oh, you cut that segment too early,"
Right.
and it'll be like a micro thing. And we've just found that there's such an appreciation for this brand that we've got to the stage where we're just like, right, let's just share everything. This is new, and for me, it's everything that you don't see that goes into the reality of constructing something of this caliber. That we're like, okay, how do we get here? And then sharing things like this and showing the wider team and all of the sleepless nights is cool. We saw this and we thought, we haven't shared this yet. It's cool. We're in the brand new engine room, so. Yeah, thanks for your time, mate. I appreciate
thank you
that.
guys.
Thank you, man. It's really cool.
It's pretty cool connected stuff that gives us very good traceability and insurance that everything is done proper each time. We have had a very good success rate without it, with our super skilled mechanics working here over time and really paying attention, like most car companies do it still. So here we have a Jesko engine pretty much finished.
I still can't get over how compact it all is.
Yeah,
You know.
1600 horsepower and 1500 Newton meters. And on 91 octane US, meaning 95 Swedish, we did a test how much is the maximum power you can get out on the lowest grade fuel you can kind of buy in the market. And close to 1300 horsepower on a 5 liter.
Out of just pump gas.
Well, not even 98 or
Not
99 or
Just
100. Like
standard
95 European and 91 US, which is about the equivalent.
Yes.
It was 1290 horsepower or something, out of a 5 liter, with catalytic converters and exhaust treatment and everything. And
How
of course,
does
you put
the,
the 85, you get 1600.
Yes.
It's the most power dense powertrain that is certified for cars that I've ever seen.
That's quite a quote.
Yeah.
Obviously, when people think Koenigsegg, they think speed, right? And I understand that. But when we went for a drive in the Jesko around town,
Right.
I think it's as impressive that you can make something with so much power so usable.
It's the hidden secrets of our cars that
Yeah.
they have this incredible performance, but they're everyday usable.
So these are your original hangars?
Yeah, that's where we started, hangar
Yeah.
1, and then we got into hangar 2,
Okay.
and then 3 and 4 that we completely rebuilt. They were not 2 stories
Sure.
or that facade.
Right.
So they're all now completely renovated together with the new facility. So now finally we have some space.
You got lots of space now.
We've been cramped for forever,
Yeah.
and suddenly we have room to spare. It's
No,
a
it's
kind of a
really-
strange
it's really
situation, going from
Yeah.
very little space to something to grow into.
Where are you at on the employee family size now?
Yeah, I think we're hitting 660, 670 employees.
Wow.
And
It's like a J curve over the last few years. Huh?
yeah, I mean we've grown from 200 to over 650 in less than 3 years.
That's growth.
So here we have test.
Hey, how you doing, guys? Good. Hey.
Hey,
man.
recognize that one?
How's things? You good? Good.
So it's
Oh,
four wheel torque vectoring dyno
The rear is 5,500
per unit.
Per unit.
Ah.
And in the front, a little less, 3,500.
So
Okay.
what do you say, 5,500? So
Yeah.
11,000 on the rear axle, and
7,000 on the front.
so it's like 18,000
Okay.
Newton meters.
So
Could you show us
Substantial.
the hovering function? It's pretty cool.
And we can take
How much does one of these weigh?
This is 3.5 tons,
One
each,
unit.
Each one.
each one.
3.5 tons
Yeah, so it's twice the car almost.
per unit.
Yeah, we turn on the compressed air.
Okay.
You know, you have those hovercraft going over Dover to Calais.
Yes, yeah.
We kind of borrowed that technology.
That's how you move it. You
Yeah,
are
it's-
kidding me. Look at this.
You can move like with your fingers.
So this is 3.5 tons. That's awesome.
It's really good.
That's really good.
So we can set it up for different cars. You have a lift table, you have sprinkler systems, you can connect data logging, and then you can heat and cool the room, and you control it from in there. And you can do simulations of different tracks, top speeds,
Really?
just flooring it flat out.
That's a big fan. Wow. And so you've effectively had this room custom built to spec.
We just ripped the space out and have
Yes.
everything custom built. So my son Sebastian contributed with some design of the black
looks
roof
awesome.
with his laser sword
It looks
things.
really cool. Mega. And all of this, so these are
These are kind of the controls. On top of the roof here,
Yeah.
we have like big coils. These are all electric. So we're taking out this energy from the car, sending them into the grid,
right
recuperating the energy. But we can't always send that much into the
into
grid.
it.
So as we're talking several megawatts, so we can burn some off on the coils on the roof with fans, so,
Really?
which is excessive. So.
So you're generating enough to reserve some of the grid,
Yes, absolutely. Yeah,
or even more so.
yeah, for the building and the grid, absolutely. And you have one of these
Absolutely nuts.
on each side. These are kind of for intercooler air feeds,
Okay.
so you can blow air into different fans and things. And then for the exhaust, you have this
So
kind of thing you can hook up here. So like a collector for fumes.
One of the reasons we love sharing all this stuff is I just think it sets so much context as to what goes into these cars. Like, you know, it's everything. Honestly, for me and from what we picked up in the comment section, the value is in all of this crazy kit and innovation that has gone
Let's
into
continue.
it. Let's continue. Yeah, because there's so much wild stuff.
You have one.
Wow.
You see, it's a similar setup with these
Yeah.
kind of energy collectors. So that's one dyno for e-motor inverter, and here's another one. And here you can see dark matter in an aluminium casing. In the car, it's carbon fiber casing, but here it's aluminium. So that sits there. That's a dark matter. With you can see there are 6 cables going to the inverter.
Yeah.
It's a 6-phase e-motor, world's first for automotive use.
It's like
so here we
got
kind
your
of
own
run them
hadron
and test them.
collider here or something. It's it's a crazy science lab.
Oh, there we have a frontal crash test.
Oh yeah, wow.
We have we were using the monocoque as actually speaker encasings, because it's the stiffest area of the car, and I haven't seen anyone else do that using the actual monocoque.
So you've got
Front.
like
So there's a speaker here, there, and then of course you have a big subwoofer in the rear, and then you have in the doors and in the dashboard. But you get that super rigid speaker encasing for the best possible sound.
so these are like sort of amp cases for speakers almost.
It's the box where you. I mean,
Yeah.
if you have a home speaker, you have
Yeah.
a box, and you want that as stiff as possible
Yeah.
for the best sound. So we
What better than a carbon one?
so we actually had to kind of simulate the crash testing everything with the speakers in place.
Really? Yeah. I would imagine that was a first, right? Yeah.
Yeah, because we've never done it before. I don't think anyone else has,
No.
as far as I'm aware.
Look at this. Do you have all the tubs different if it's a left-hand drive or a right-hand drive? Or is it, are they
There's
just
only a
built that way?
machining difference here. because this has to do with the HVAC. So on our previous Koenigsegg's, we can actually convert left and right hand drive cars after the fact.
Right.
So this one we can't, because these are kind of machined differently depending on left. But the tub tooling is the same. Here we can see a Gemera seat actually. It's interesting as we have, this is our polish department, this is a test seat. So the retractor actually sits underneath here.
Okay.
And then the belt rolls around the shape of the seat. Well, this is the the trace for the belt. So it's twisted to follow the curve of the seat. As we don't have any B pillars, we needed the belt in the seat.
Right.
But we wanted a lightweight seat. So there is one kind of, how should I say, maybe compromise that you can't, it's a bucket seat.
Yes.
So you can't tilt it like this, but you can tilt the whole thing, move it up and down and backwards and forwards, and the steering wheel of course. So there's a lot of adjustability. But what's interesting about this seat, it's an air core seat like the wheels.
Is that?
So it's hollow inside. And we have this core we lay up positively, so you get the best possible structure. But also these cores allow us to have kind of interior walls. It's hollow, but you have interior carbon fiber walls stiffening up the seat so we can make it thinner. So it's the second product we have with our air core technology that we developed for the wheels.
Yeah, chicken teriyaki time.
Right, yeah, getting ready for lunch. Maybe.
Lunch is on. Wow, I love this. Cool, huh?
Yeah, so this is lunch
Brilliant.
room.
Lunchroom. It's very cool. So when I first started coming here, this was the reception area, like about here?
Correct. Yes.
Right.
So you up for some lunch, or?
Yeah, I'm down for some lunch.
Yeah.
Brilliant. Awesome.
Great. I'll have some.
That was great. Thanks.
Yeah, perfect.
Thank you. I've been fortunate to walk these factory halls with Christian over the years, but this time was different. This family of engineers is on a journey to a totally different stratosphere, and today was a tangible immersion into the very beginning of the next chapter for Koenigsegg.